This video will be over AP questions involving chapter 1 and 2 topics. It's kind of a mix between limits and derivatives. So please do not watch this video until after you have tried these on your own. That is the most beneficial way. But I do want you to have access to instant feedback if you get stuck or explanations. So try these on your own and then come back and watch this video and you can check and see if you've got the same answers or if your thought process was correct. So again, feel free to use this video as you need. You can fast forward and just go to questions that you were confused about or however. So the first one says, let f be a function defined above. Which of the following statements about f is true? And it's asking about is at x equals 2, which you can see is where it switches. Does f have a limit? Is it continuous? And is it differentiable? So the first one is, does f have a f has a limit at x equals 2. So you want to see what it's asking about is the limit as x approaches 2 of f of x, right? Okay, so normally you plug this in, but because there's this, it's a piecewise function, because really you have to make sure the right and the left are the same, and that is, so if you look, this to just kind of get an idea of what this graph is, what's happening with this graph. If it's just x equals 2, it's not greater than or less than for this branch, then that's just a point, right? That is just a point at 2, 1. So we really care about this function and is the limit exists here, even though technically at 2 it's not this function, it's this point, but a point doesn't tell you about a limit, right? Because we don't really know what this function looks like, but if it could be something like along the lines of this and a hole here, and then that point is at 2, 1, and we don't know if that point necessarily fills that in yet or not. It could be above it, like if this is at 2, it's saying this is this whole function, but at 2 it's undefined, there's a hole, and then they're putting a point, and now that might fill it in if this is a y value of 1, or it might be above or below it. We're not really sure yet. So we need to find the limit of actually this original function. So we're going to find the limit as x approaches 2 of x squared minus 4 over x minus 2. So if you think about plugging that in, 2 squared minus 4 would be 0 over 0. So you can either use L'Hopital's rule or factor. So it's up to you what you do at this point. If you factor, you would do difference of squares, x minus 2, x plus 2 over x minus 2. So those cancel. And so your limit as x approaches 2 is going to equal the same as just x plus 2. So if you plug that in, 2 plus 2 is 4. So the limit is 4. You can't use a point for a limit. So if you notice that, now I kind of drew this picture wrong then, because this y value of my hole is 4. So that point is beneath it at 1. So we know that the limit does exist because it equals 4. So check. The first one's for sure true. Now, is it continuous? It is not, because the limit doesn't equal f of c, f of 2, right? F of 2 equals 1. At 2, this function equals 1. But that does not equal that limit. So it is not continuous. That point didn't fill in the hole. So that one is not true. And now if a function is not continuous, it cannot be differentiable. So be careful. You had to know that fact first. Because normally if it was continuous, what you would do is take the derivative of the top branch, the derivative of the second branch, and then replug in 2 and see if they're equivalent. And in this case it would. Like if I took the derivative of this, it'd be 2x. Wait. No, because you would have to use the quotient rule. But just know, we don't even need to do that because it's not different. It's not continuous. So, if not continuous, can't be diff. So that one can't be true either. So the only thing that's true is that the limit exists at f equals 2. The answer is A. So the next one says the graph of the function f shown in the figure above has a vertical tangent line at the point 2, 0. So that's going to probably be important. That's talking about right here. You can see you would draw a vertical tangent line because it switches concavity. And a horizontal tangents at the point 1, -1, and 3, 1, which we know the slope there is 0. For what values of x in the interval -2 to 4 is f not differentiable? So when is it not differentiable? It's not going to be differentiable if it's not continuous, like we just said in the previous problem. If there is a sharp turn, or if there's a vertical tangent line. It can be horizontal. So where on this graph is it not continuous? Where is there a discontinuity, a jump, hole, or vertical asymptote? Right here, right? This is a jump at x equals 0. So at x equals 0, it's not continuous. So that is 1. X is values of x. And then, does it have any sharp turns? No, these are not sharp turns. And vertical tangent line is at 2. So that's another spot. So that would be this answer. Okay. Next one would be the graph of a function f is shown above. At which values of x is it continuous but not differentiable? So what does it mean to be continuous but not differentiable? These two spots, right? At a sharp turn and vertical tangent line is continuous but not differentiable. So if you look on this graph, where is there a sharp turn? It would be at this point, at A. Is there any vertical tangent lines? There's not gonna, it's something that looks like this where it just switches concavity all of a sudden. And there's not. So the only spot that it's continuous but not differentiable is A. And if you're watching, just for a quick review, at B, is it continuous? No, because it has a hole. Does a limit exist at B? Think about it. Hopefully, you said yes. The limit exists at B, but it's not continuous because that point f of B doesn't equal the limit. This is the limit, that is f of B, and they're not equal. At D, is it continuous? No, because it's a jump, right? So the limit doesn't even exist. So at B, the limit as x approaches B exists, but you don't have to write this for the thing. I'm just trying to review topics. Exists but not equal to f of B, because f of B is this point up here. Now at D, the limit doesn't even exist because the limit as x approaches D from the left doesn't equal the limit as x approaches D from the right. So therefore, the limit as x approaches D does not exist. And if the limit doesn't exist, it can't be continuous because then it can't equal the y value. Okay, so hopefully that kind of helped to break it down on a graph. Next one is let f be a function shown where, now you should recognize this as the definition of a derivative. Which of the following must be true? So when you see this, limit as h approaches 0, you read that as that is equivalent to f prime of, and then whatever this number is that you're adding to h is your x. So if they kept that x, then you would write x, but if it's a 2, you write 2. So these two things are the exact same. This is just the formal definition of this. So what it's really saying is f prime of 2 equals 5. So what must be true? If the derivative of 2 equals 5, is it continuous? Well, if the derivative exists, you can't have a derivative if it's not continuous. So if the derivative is a number, that means it's differentiable. So it has to be continuous at 2 or you couldn't have a derivative. And now it also is differentiable because it is a number. Just differentiable just means the derivative exists. Now this one's kind of weird, but it says the derivative of f is continuous. So technically, we don't know that. We don't have enough information. We just know that the derivative of 2 equals 5, but we don't know it's continuous. How could it equal, let's say this is f prime of x, and we know at 2 it equals 5, but what if there was a jump on your derivative graph for some reason? Right? We know f prime equals 5, but we don't know that it's actually continuous. The original had to be continuous, but we're not sure that the derivative is. So that would be 1 and 2 only. On the back, this is a bunch of derivatives questions. Oh, my pen is bleeding through bad. So on this one, first one on the back, it says, if f of x is x squared plus 2x, then what's the derivative of f of ln of x? So there are probably different ways you could go about this, but the easiest way is work your way from the inside out. First, we need to know what is f of ln of x. Before you worry about the derivative, we need to plug ln of x into our f equation, right? So I'm going to come over here where I didn't already write. And we want to know what is f of ln of x. So we're going to put ln of x into our f equation. So everywhere there's an x, you put ln x. So it's squared plus 2 times ln x. Okay, so that is f of ln of x. Now you just take the derivative. So now we want the derivative of f of ln x. So we take the derivative of this equation. So how do you do the derivative of the first term? It's going to be chain rule. So you bring the 2 to the front, keep the inside the same. That would be exponent 1 times the derivative of the inside, which the derivative of ln of x is 1 over x, plus, keep your coefficient 2, always keep coefficients, times the derivative of ln of x is 1 over x. So you can clean this up, and this would be 2 ln x over x, when you multiply it by 1 over x, plus this would just be 2 over x. And now because they have the same denominator, you can add the numerators, and I think that's an answer choice. Answer choice A. Okay, next one is again a lot of chain rule, right? So anytime you have an exponent on a trig function, you need to rewrite your problem. The original that you're taking the derivative of is the same thing as cosine of x cubed, and then that whole cosine is being squared. So what is the outermost thing? It's the squared. So what do you take? If you work your way left to right, you're going to do it wrong. You're not going to do the derivative of cosine first. You're going to do the derivative of the squared first. Okay? So always, always, always rewrite those and put it on the outside of your cosine or sine or whatever trig function. So bring the 2 to the front. Keep the whole inside the same. Which then subtract 1, so that would just be exponent 1. Times the derivative of the next outside, which would be cosine. The derivative of cosine is negative sine. Still got to keep the inside the same. You can only do the derivative of one thing at a time. And then you still got to do times the derivative of that most inner thing. So it was like 3 chain rule. So then 3x squared. And then we could clean this up, take all your coefficients, which is a 2, a negative, and a 3. So that would be negative 6 x squared times cosine x cubed times sine x cubed. Is that an answer? Answer choice D. Okay, next one is an easy problem if you know that these absolute values are not going to change your derivative. It's just restricting the inside of your natural log to be a function and not be undefined. So you can treat them like parentheses. So those aren't going to show up in your derivative. It is still going to be just 1 over the inside times the derivative of the inside, which then you could write it on top of each other, so 2x over x squared minus 1. There should be no absolute values in for your derivative. That is always the case for natural log. Okay, this next one's kind of like a puzzle. So it says, let f and g be differentiable functions with the following properties. So it says, I don't know if you can, this one didn't print that well. G of x is greater than 0. So what is that telling you? G of x is positive, right? And it's greater than 0, not equal to. And it says f of 0 equals 1. So then if h of x equals f times g, and h prime is just f times g prime, then f of x must equal which one of these? So to know where to start is first you need to think about this, because when you see this, to find h prime, you should think product rule. And that doesn't necessarily look like a full-on product rule because it doesn't have plus the other opposite version. So let's go over here and work it out ourselves. If we were going to find h prime of x, and it's f times g, then you would take the original second, so g times f prime, plus switch it, f of x times g prime. So now, if you notice, f of x times g prime is what they want you to be left with. So how is h prime of x going to equal just that? Then what does this whole first term need to be? Right? This is going to equal this only if this whole first term equals 0. That's the only way h prime is going to equal just this. So we need this first term to equal 0. So how is this first term going to equal 0? Well, either g of x needs to equal 0, or f prime of x needs to equal 0. Well, if you think about it, g of x, it says it's greater than 0 for all values. So if it's greater than, it can't be equal to. So that's not a possibility. So we know f prime of x needs to equal 0. So if we go to these answer choices, it's saying which one of these options is the original f. Well, think about which one of these will f prime be 0. So if this is f, if f is f prime, we don't know that if you take the derivative of f prime, then it's going to be 0. That doesn't necessarily mean it's 0. If f is g, the derivative isn't necessarily 0. That could be anything. The derivative of e to the x is e to the x, which isn't 0. The derivative of 0 is 0, and the derivative of 1 is 0, right? So both of these are options, but none of these, the f prime equals 0 all the time. Now, that's why they gave you the second piece of information for which one of these is f of 0, 1. Well, if f of x equals 0, then that would mean if you plug in 0, it always equals 0, which that doesn't match. That can't be it. But here, if f of x equals 1, then f of 0 would be 1, which matches what they said, so it's e. So that is a very challenging problem. You have to kind of think outside the box. Okay, last two. First one is y is x squared times sine of 2x. Get the derivative, so that's straightforward. Hopefully you see that you're going to need product rule, and you're going to need chain rule for the second, for g prime. So that would be the original second, sine of 2x, times the derivative of the first, 2x, plus, switch it, the original first, times the derivative of the second, which would be sine, nope, not sine, the derivative of sine, which is cosine, keep the inside the same, times the derivative of the inside, which would be 2. And then you could go from there and kind of see which one would be the same as your answer, clean it up a little bit maybe. We can see this definitely doesn't look right. And so it looks like they factored out a 2x from each term. So the first term you'd be left with just sine of 2x left once you factor out this 2x, and then here's a 2, and take out one of those x's. So then we're left with plus. We took out the 2, so I'm kind of doing this out of order. And we took out one of these x's, so you're left with still an x, and then your cosine 2x, which would be answer B. This one doesn't have that extra x from the x squared. Okay, last one. Here's your original. They just want f prime of 0. So we're going to first get f prime of x before we get f prime of 0. So the derivative of natural log is 1 over the inside times the derivative of the inside, which derivative of x is 1. The derivative of 4 is 0. The derivative of exponential, it stays the same, times the derivative of the exponent, which would be negative 3. Now you can clean that up, or just go ahead and plug in your number. So f prime of 0 would equal 1 over 0 plus 4 plus e to the negative 3 times 0 is 0 times 1 plus e to the 0 times negative 3. So what do we know about e to the 0 equals 1? You need to have that memorized. Anything to the 0 is 1. So this would be 1 over 4 plus 1 times 1 plus, oh, I could have changed that to minus, huh? Because that's going to be 1 times negative 3. So 1 plus negative 3. So then, I'm running out of room. I'm going to come over here. That'd be 1 over 5 times 1 minus 3 is negative 2, so negative 2/5, which is L. Okay, so hopefully that helped you. Check your answers, get some explanations if you needed them. If you need any more help with anything, please let me know.